before starting my presentation, I would say thank you to the organizing committee that give me the possibility to present my work regarding the effect of BOPP packaging on the shelf life of Citrus sinensis cultivar biondo di Caulonia, a typical fruits of Calabria region in south of Italy. Citrus is the most produced tree fruit crop in the world, and its consumption is inversely associated with the presence of several diseases due to their high content in secondary metabolites that are characterized by a variety of biological functions. In particular, our work was done on Citrus sinensis or sweet orange. This is an hybrid between mandarin and pomelo and is distinguished by a slight, delicate and fresh smell. And as reported in literature, it was characterized by several health properties, including antioxidant activity, anti-cancer activity, prevention of osteoporosis, and also prevention of disease by a direct action on the immune system. So, the organoleptic and nutritional quality of a fruit is the result of the combination of different factors, not all of which can be traced back to the production in the field. In fact, a great significant and important action depends from post-harvest management of these fruits. Fruits are non-climateric with persistently low respiration and ethylene production, and low temperature storage is considered of primary importance in post-harvest technology. In particular, for citrus fruits, decay depends from different physicochemical causes and biological causes. Among physicochemical causes, oxygen, temperature, light, humidity, pH are the most important, whereas among biological causes, we need to remember microorganisms, enzymes such as polyphenol oxidase or lipoxygenase and macroparasites. Okay, so the shelf life is the time during which the food product will remain safe and retain desired sensory, chemical, physical, and microbiological characteristic. And it begins from the time in which the product is ready at the end of processing and finished when is not more acceptable for consumers. The purpose of food packaging is to preserve the quality of food from its manufacture to consumer use. The most common quality losses are associated with the water vapor and oxygen transfer. The research of barrier properties is very important from a technological point of view. Thus, the different part of the material science field has many applications to food packaging on a laboratory or industrial scale. In recent years, bio-oriented polypropylene film with anti-fog properties was developed. This is one of the most commonly used plastic film in the flexible packaging industry. It was characterized by a good rigidity, a high tensile strength, an excellent optics, and also a good water vapor barrier properties. So, the aim of this work was to investigate the effect of BOPP packaging on the quality of stored orange of cultivar biondo di Caulonia. For this purpose, citrus fruits were collected in Caulonia, close to Reggio Calabria, in south of Italy, and fruits were selected for size, appearance, and lack of defects. Then citrus were packaged with BOPP packaging, and The juice from these fruits was monitored for qualitative parameters, bioactive contents, and antioxidant activity. Okay, in the context of packaging analysis, the analysis of gases in packaging is defined as head space and its volume inside the package, not occupied by the product, is very important. As possible to see by the table, in orange fruit wrapped in BOPP film, an increase of carbon dioxide concentration and a decrease of oxygen concentration was observed during 45 days of storage. Then we have extracted the juice to investigate the qualitative parameters. The juice was extracted by cutting the fruit in half and by using a commercial chicken juicer. And on this product, several juice quality parameters were monitored. In particular, we monitored the pH that did not present many difference among wrapped and not wrapped sample, whereas a certain variability was observed in total soluble solid. In fact, as possible to see by the table, you have a slight variation in both cases, in wrapped and non-wrapped sample. And in particular, in BOPP wrapped sample, the treatable acidity decreased by 11.28 to 9.43 grams per liter of citric acid at the end of the time of observation. This is probably due to the decline during the fruit ripening of organic acid that normally are used for respiration or are converted into sugar. Taking into account that color is another important quality attribute in the food and the bioprocess industry, we have decided to monitor also CLAB parameters, because we know that color is important for consumer choice and preference. And color is governed by chemical, biochemical, microbiological, physical change that occurs during the growth, maturation, post-harvesting, handling, and processing. As possible to see by the graph, in both cases, wrapped and not wrapped sample, a chroma reduction was observed at the end of storage. However, in a BOPP wrapped sample, there is a major retention of pigment that are responsible of a better color. Okay. The study was done also on the phytochemical content of the main bioactives that are known to characterize the citrus fruits, and in particular total phenols, total flavonoids, and the total carotenoid content, and also ascorbic acid content. In general, BOPP wrapped sample are characterized by a great retention in both TPC and TFC, also at the end of storage. And the same trend was observed also for TCC. It's important to consider also ascorbic acid, because orange juice is a rich source of ascorbic acid that is a phytochemical characterized by a great antioxidant potential, and change in ascorbic acid are indicator of both enzymatic and non-enzymatic degradative reaction that taking place during processing or citrus fruits storage. And this is a major problem associated with the quality of orange juice, because normally a reduction, a loss of ascorbic acid during the storage was observed. As possible to see in the table, juice derived from fruits wrapped in BOPP sample are characterized but of a certain reduction, but this reduction is less drastic than in the case of control. Then we have done the quantification of the main flavanone that characterize the juice, and in particular hesperidin and narirutine, and we have found that in each case, hesperidin was dominant, and that during the 45 days of storage, the both flavanones unfortunately are gone to a decrease. Okay, so another important aspect of our work was to investigate the antioxidant potential of this juice, of the juice derived from orange wrapped in a BOPP film. Oxidative stress is defined as an imbalance between general of free radicals and the activity of antioxidant defense. In normal condition, cells are able to balance the production of oxidant and antioxidant. However, the excess formation or an insufficient removal of these radicals, both reactive oxygen species or reactive nitrogen species, are responsible of damage to lipid with peroxidation, protein with degeneration and disactivation, and DNA with the mutation of pyrimidine and pyrimidine bases. And this is linked, unfortunately, with metabolic, cardiovascular, and neurodegenerative disease, and also with cancer. So, taking into account that citrus is a promising source of bioactive compound, that we have quantified this bioactive compound, we have decided to investigate the antioxidant activity of this juice. And for this reason, we have used a multi-target approach that use different tests, and in particular, we have used the DPPH and the BTS test to investigate the radical scavenging potential of our sample, whereas with FRAP test we have determined the ferring reducing ability power of this juice. In DPPH assay, a reduction from 90.8 to 62.27 was observed in control, whereas in wrapped sample in which BOPP film was used, this reduction is less important, since we have a reduction to 72.42 at the end of storage. A similar situation was observed also in a BTS test with values that starting from 72.79% and arrived to 53.78% in control and 76.78% in wrapped sample, and also in FRAP test. Person correlation coefficient evidenced the influence of a phytochemical compound on this activity. And as possible to see in this table, in particular, the total carotenoid content is responsible of the PPH, as well as the total phenols content, whereas asparagine and total carotenoid and narirutine are responsible of the inactivation of ABTS radical, and asparagine and total phenols content and total carotenoid content contribute equally to the ferric reduction ability. So, in conclusion, by comparing the juice obtained from fruit wrapped with BOPP films with reference obtained by fruits not wrapped used as a control, it was shown that the content of total phenol, total flavonoid, total carotenoid content, and ascorbic acid content was better preserved, and this is confirmed also by the high content of flavanones, asparagine, and narirutine, also at the end of period of observation. The high content of bioactive compound in juice obtained by orange wrapped with BOPP films is also responsible for the high antioxidant activity. For this reason, the packaging with BOPP guarantee a better quality of starting food matrix used to obtain orange juice. And thank you very much for your